Hi, my name is Logan, and I'll be walking us through this AP Calculus extra credit problem today. Now, the problem number is 13, and the problem reads, if the price charged for a candy bar is P of X cents, then X thousand candy bars will be sold in a certain city, where P of X equals 147 minus X over 22. How many candy bars must be sold to maximize revenue? Well, first, we should write down P of X equals 147 minus X over 22. Let me do that right here. Now, you can infer that, or from what you know, that to find the revenue, since that is what it's asking, you can just use revenue equals P of X times X. Now, to solve for this, you're going to want to substitute in what P of X equals, and then distribute that X. So you're going to have 147 minus X over 22 times X. Here we go, let me move this down, I'm sorry. So, distribute that in, and what you end up with should be 147x minus x squared over 22. Now, you're going to want to take the derivative of that and set it equal to 0. So, the derivative of this, x becomes 1, and this, bring the 2 down in front because of the power rule. Now you're left with 2 of x over 22, which simplifies down to x over 11. So, you can also write it as r equals that, so then r, well, I guess it would be r of x equals that. So r prime of x now equals 147 minus x over 11. Now, that is also equal to 0, as I said before. You can add that to the x over 11 to both sides. So you're left with 147 equals x over 11. I'm sorry, I was off with the camera. Now, multiply 11 to both sides to cancel it out on the bottom, and you are left with x equals 1,617 units. Now, I know you're saying, how do we know? What is the max revenue that it gives you? Well, plug it into your formula that you came up with for revenue, which is P of X times X. So, you're going to plug in the 1,617 units. It will be 147 minus 1,617 over 22 times 1,617. It should look like so. R of 1,617 equals that. So, you're going to end up with 237,699 minus 118,849.5. That is when you multiply in the 1,617, and then that's what you're left with. So now if you subtract 118,849.5 from 237,699, you actually end up with this number. Oh, my bad. This number, 118,849.5. That is your max revenue, and it is in dollars. That is how much you would make by selling 1,617 units. Now, in the problem, it asks that we maximize the revenue. To be sure that this is a maximum, we need to pick a point, so a value for x, that is above and below what we came out with. Now, once we pick the point for x, we're going to plug it back into our r of x function, and if your total or your max revenue is less than what we have here, both times we know that we have a maximum. So I picked for below x equals 1,500, and for above I picked x equals 1,700. For x equals 1,500, you have 147 minus 1,500 over 22 times 1,500. The number you get is 118,227.27. Now, not much, but it is below it. So far, so good. With the number above, you have 147 minus 1,700 over 22 times 1,700, and you come out with 118,536.37. Again, not much, but it's below it. So we can then be 100% certain that X being 1,617 units is the max units to be sold, and gives us a max revenue of $118,849.50.